welcome to the video lecture series of operating system. In today's session, we are continuing with the topic input-output management and disk scheduling. Specifically, we are going to focus on disk scheduling part. Myself, Kunal Panchal, your instructor. In this particular session, we are going to discuss a third disk scheduling algorithm, which is nothing but scan disk scheduling algorithm. Okay, scan disk scheduling algorithm is also known as elevator algorithm. Okay, and you know very well what is elevator in real life situation. So by having this understanding, let us start the working of scan disk scheduling algorithm. So again we have one example through which we are going to understand the working of scan disk scheduling algorithm. So in this particular example, again we have 200 tracks. Request queue track numbers are same as we have discussed in SSTF and FCFS. Same track number we have with same sequence number, and current head position is also same, which is nothing but 50, and we need to calculate the total number of track movements by read write head. Okay, but in this particular example, one more thing we need to have as an input. Then and then we can execute the scan algorithm, and at the end we can find out the total number of track movements. So that extra thing I have highlighted with the help of yellow color. So direction needs to be given to you as an input in your examination if you are talking about scan scheduling algorithm. Direction is not required when we are dealing with FCFS. Direction is not required when we are dealing SSTF, but it is required when we are talking about scan scheduling algorithm. So direction is given. So direction is towards the lesser value first. Means suppose we need to start our journey from the 50th track number. Yes. Okay. So once you start the journey from 50th track number, so first of all we need to travel in a direction in which it come the lesser value first. Okay, so whatever the number of requests we have, which value is less than the value of current head position, which is 50 in this case, that request will be satisfied first. Okay, so let us discuss how we can execute the scan algorithm. So in this case, again we need to start the journey from 50, and because direction is given, so specifically in that direction we need to travel. So it is towards lesser value. So whatever the number of requests we have, like 34, 11, 41, these three requests is nothing but the value of these requests are less than the current head position. So these requests will be satisfied first. Fine. So we will start the journey from 50. Then first we will satisfy the 41 request, then we will satisfy the 34th number request, then we will reach to the 11th track number. Yes, and because this scan algorithm is working like an elevator, just like in real life practice, we have a lift. If we have more than 7th floor in a particular building, definitely there will be one lift. So the working of, you need to focus, or you can compare the working of lift as far as this scan algorithm is concerned. So same scenario is applicable in this particular algorithm. So you can see that at 11th track number, the number of requests is completed towards that direction, but still we have traveled towards the last track number in that direction, which is nothing but zeroth track number. Why we have reached to zeroth? So you know very well, once the lift is started at and it is going, once it is in one go, it will reach to the end point, and in another go, it will reach to the last request. Okay, because there are chances in one go, dynamically, there can be some, people send a request or press a button to use the lift services. So there is a chance. So that's why in first go the lift will start from the zeroth location to the nth location, and in second go it will reach to the last request, not last. We can say track number in this case, or we can say last position of that lift. It will not go in second go, in second travel. Okay, so in that way it works. So these things you need to keep in your mind when you started a journey in a particular direction, whether you are going towards smaller value or larger value, that will be given to you as input. So in that case, it doesn't matter whether you want to go towards lesser value or larger value, but whatever the direction you have picked as per the input, in that direction you need to reach to the last position, or we say last track number of that direction. Okay, and then you have to come back. Fine. So at zeroth position we will come back to satisfy the another request that we have. So once it is come back, the first request is nothing but 60 will be satisfied, then 79 will be very satisfied, then 92, and then 114, and at last 176 request is satisfied. And once 176 request is satisfied, then it will not reach to the last, or we say 200th track number. It will not reach to that. It will stop its execution to the last requested track number only. Fine. So as far as scan algorithm is concerned, in one go, in a direction you have started your journey, in that direction you need to reach to the last position, irrespective of whether the request is there or not. You need to reach to the last position and then you have to come back. But while in second go, you need to reach to the last request instead of last track number. So these things you need to keep in your mind while executing this scan algorithm. So in this case, how many total number of track movements? You can easily find out 50 minus 0 plus 176 minus 0 is equal to 226 total track movements by the read-write head. Okay. So what are the advantages in this case? It works better when we have dynamic request, definitely. As I told you, in one go, if there is a runtime request arrive, so definitely we can satisfy at that time. So when we have dynamic request, in this case, scan algorithm works better as compared to other algorithms, because the other algorithms that we have seen so far, it based on the static request only. That algorithm satisfy the static request only. Fine. Now, what are the disadvantages of this algorithm? So, the main disadvantage is what? Once it change the direction in execution, means a single direction is completed and it will start the journey towards other direction. And once it is started, if any request arrive dynamically, that request will not be satisfied, because if direction is changed, now it will not come back to the previous direction and satisfy that request, even though there is a dynamic request. That is a limitation of these algorithms. So for dynamic request, starvation problem can be there, because that request has to wait for a long period of time to get its chance. Fine. So definitely there is a starvation, because that request was came first as compared to the other request. Still that request will be satisfied later on. So definitely there is, in terms of dynamic request, there is a starvation. Fine. So I hope the working of scan algorithm is clear to you. Thanks for watching this video. See you in the next one.